excited to be featuring Nassim Haramein here in Canada first. And I watched his presentation in Montreal yesterday, and I can't wait to watch it again because it's one of those things, one of those fields of study, wrapping your mind around these concepts. It's just awesome to keep revisiting it. So without further ado, the Connected Universe. All right, so Nassim's going to talk a little bit more about the upcoming film that's going to document his work. And there may be some of you in the audience that may not have heard of Nassim's work in the Resonance Project. Anybody? Oh, wow, okay, so we're good. All right, but I got to do the man justice. He's been doing this for a long time. And for those of you who might not have heard his background, Nassim was born in Geneva, Switzerland back in 1962. And as early as 9 years old, he was already discovering universal dynamics of matter and energy, which led him on a journey towards pioneering a new approach to quantum gravity and continual developments in unified field theory. He actually grew up in Eastern Canada with an innate reverence for the design of nature and a determination to discover the basic building blocks of creation. Nassim's dedicated most of his time to his independent investigation of physics, geometry, chemistry, biology, consciousness, archaeology, and various world religions. He's clearly a man after my own heart here. His dedication to scientific exploration, combined with his keen observation of the behavior of nature, led him to a specific geometric pattern, which is the core of his approach and new perspective in unified field theory. He's fluent in both French and English, and he's been delivering lectures and seminars on unification theory for over 20 years worldwide. In 2003, he founded the Resonance Project Foundation, and as its director of research, leads teams of physicists, electrical engineers, mathematicians, and other scientists to explore the frontier of unification principles and their implications. Nassim's lifelong vision of applied unified physics to create positive change in the world today is reflected in the mission of the Resonance Project Foundation, and he shares the developments of his research through the scientific publications and educational offerings through the Resonance Academy. So let's give a warm Toronto welcome to the one and only Nassim Haramein, ladies and gentlemen.
Hi, everybody. Hi. Thank you. Thank you. Thank you so much. It's great to be here. Wow, it's my first talk in Toronto. Hopefully not. So I'm excited to share this presentation with you. I've been kind of going around, you know, I was in my cave in my lab, kind of cooped up for almost 3 years, and I just started to tour again. I was in Paris a few weeks ago, in Belgium, and Montreal yesterday, and you know, it's remarkable the response I'm getting, but as well, where are people at, and how much, engineers, scientists from all flux of life are like coming to this, and it's amazing the momentum behind it. And why is there such a momentum? The Connected Universe movie, I believe, got the best crowdfunding result in history of Indiegogo. Remarkable. We needed to raise funds to improve some of the, to put and improve some of the animations in the movie. And this movie is going to be incredible. And it's due to your generosity. So thank you so much, everybody, for participating and being involved. And it's exciting to see. I want to present to you today this view of the connected universe that's emerging in science, because it says a lot. It says tomes about who we are, the universe we live in, and how we interact with it. And most people think of this kind of stuff as stuff that is kind of woo-woo, and it's kind of nice philosophical idea that we're all one and all this stuff. But actually, the physics are now showing us that it's really actually the way things work. And that you can take these concepts, write the physics, and get very accurate, very fundamental understandings of the forces of nature and the material world in it. And it's exciting as well, because it not only unifies the forces of physics, but it unifies the concepts that are typically polarized between spirituality and science, which, all of a sudden comes together, where you realize that the material world is actually an expression of what we call the spiritual world, or that what we call spirituality is actually the physics we haven't quite understood yet. And so this is really, really critical, because it has the potential to launch our society into a whole new way of interacting with nature. So you can think of the universe as the standard model, and the mainstream scientific community typically think of as this random entropic system that always moves towards disorder, and that where things happens by chance, and literally quantum theory is written in such a way that it is a statistical analysis of the probabilities. Or you can actually, from observation, come to different opinion about the universe. Because the mere fact that we observe the biosphere all around us, and the complexity of even just our being in the biosphere, kind of points to a universe completely different than that one. Because this complexity and this very advanced, systems that we see in the bioorganisms and in the biosphere systems does not point to a random, entropic behavior of nature. It actually points to something that's highly organized, highly communicative, like that is talking very much so, and that is highly coherent, and that strive for coherency, for complexity, that moves towards complexity and advanced systems. And so how we reconcile these two views? Well, let's assume that we think of the universe a little differently. There's a reason why the mainstream scientific community is insisting that the universe is random philosophically, and that there is no organizing systems, is because they have been for a very long time trying to get away from religions and dogma, and so the idea that when you start talking about there's organization in the universe and so on, the tendency is to think, oh my God, he's gonna start talking about God organizing the world or religions, and that's what science wanted to get away from. And in doing so, they've created their own dogma. And that is not necessarily an appropriate scientific approach. That is, as you discover that there is incredible complexity, and that mathematically the concept that the universe is random doesn't actually work out, you should start looking for alternatives. So there's an alternative to going to some religious beliefs, but as well understanding that the universe may be much more advanced in its capacity to relate to itself than previously believed. That it's not just a big boom that happened and somehow miraculously we got here, right? And we'll talk about that. It would be really miraculous, right? So a unified view of the universe. If the universe is unified, what does it look like? And how, this is what I wanted to know. It's like when I was young and I was in nature, and I'm a sport jock, I'm like crazy on sports. I used to be a ski coach and a ski instructor for many, many years. I'm a climber, I'm a backcountry skier, I'm a scuba diver, I surf big waves in Hawaii all winter long, I'm into it, right? And I'm in nature, and when I look at nature, I look at this incredible thing that's happening, this incredible miracle that's happening, and to me, it seemed unified, like the bee somehow knows that it's got to go to the flower, and it knows how to deal with that flower so that there's more flowers that happens, and the whole system and everything is just tuned perfectly so that all this stuff happen. And literally this is called the fine-tuning problem in physics, okay? It's funny because it's called a fine-tuning problem, but it's not a fine-tuning problem, meaning it's like a big problem, right? Because the fine-tuning problem is that, like, if the electromagnetic field in the universe was just a little different and the gravity was a little bit different, like anything, anywhere, and any shape a little bit different, none of this would happen. Like it would all just go, it just wouldn't happen. And so it's kind of puzzling, like, okay, why is it like actually tuned perfectly for this to be happening, right? And, there's views which I think is kind of a way to avoid the issue, saying, oh, well, there's infinite parallel universes and we just happen to be in the one that's tuned perfectly. All the rest are like a big mess. Okay. Well, other than that view, maybe there's another thing that it's tuned perfectly because it actually knows what works and what doesn't work, right? Maybe it's actually talking to itself. Maybe there's feedback. Maybe, the fact that we see feedback everywhere in nature is actually because it's an expression of what's happening at the much fundamental level in the material sciences, in the physics. Maybe there's feedbacks in the physics. Maybe there's something talking to something in physics, right? Maybe it actually knows what it's doing. And maybe the fact that consciousness somehow is present is not just some random events that's kind of like miraculously happened, but it's fundamental to the way things are. So, I kind of got lost. I have a presentation to give. You know, we gotta have tea one day and talk about this. But this division in our thinking, this idea that things are isolated, things, you know, that we can observe something over here and ignore the rest of the stuff as if that thing was separate from that thing over there, is present everywhere in our society. And, you know, even in our physics, we have that. Meaning the standard physics we have today have this big separation in it. Cosmological physics basically is dealt with Einstein field equation that describes the gravity at the levels of galaxy and stars and universes and, you know, quasars and planets and this stuff. And quantum theory, on the other hand, describes the subatomic particles, the atomic structure, even the molecular structure at the very fine level. And the two don't agree. They don't agree at all. Einstein field equation describes the universe as this space-time metric that is smooth and curving to produce gravity. Like Einstein described gravity as like if you put a ball, if you put a mass, right? So it's part of the equation, mass producing curvature. So if you put a mass on a structure like a trampoline and it curves that trampoline, another ball would appear to be attracted, right? And but he didn't say actually, and this is why we actually don't exactly know what gravity is, he didn't say what space-time exactly is. So, you know, that doesn't, all right? But it says it's smooth, right? The equation says it's very, very smooth. And if you look on the quantum side, when we look at particles and how we express the physics of particles, we're finding that at the quantum level, everything is quantized. It's very defined, you know, linear functions that make boundary condition. And so it's granular, so it's not smooth at all. And so the two don't agree. And for, you know, all of his life, Einstein, after writing relativity, tried to find a way to solve unification, to bring gravity into quantum physics and find a way to describe gravity in a way that would work for bounded states of quantas of quantum physics. And literally all his life he worked on it. I mean, literally hours before his death, he was trying to solve this, right? And then something he said that was really important, he said, and I quoted that in my latest paper, he said, when we find the solution, most likely it's going to be really simple, it's going to be geometric and algebraic in nature, you know, like it'll be geometry. Because Einstein was strong on geometry, he's well known for having geometrized space-time, right? So the two don't agree. We have this split, but it's not just in physics that we have this split. You know, there's many ways we can look at this split in our society. For instance, men and women. You know, men typically think in bounded linear states, right? Like finite function, right? Like they do one thing and then they do another thing, you know. Women tend to think in more open, like infinity kind of thing, you know. They can like have the baby on the hip, you know, with the milk and, you know, text at the same time, and with their toe they're doing the dishes, and it's like, no worries, right? Kind of separate way. And you know, that division happens in many different ways in our society. So it's really fundamental in one way. It is similar to the division between spirituality and science. You know, like science tend to think in very bounded, linear way. Spirituality thinks in kind of infinities, you know, kind of way. And so the two don't agree. But the thing is And that kind of, when I used to go to physics conference some 25 years ago, and I would talk to physicists and give my presentation and kind of dodge tomatoes, I would, I would always be surprised because some physicists, and that was the opinion of most physicists at the time, and it's just because they were told that as students, so they just repeated it. But their idea is like, well, it's okay to have two physics. There's no need to try to unify them. We just have physics for the big stuff and physics for the small stuff, and that's the way the universe works. And then I'd be like, but wait, that's hurting my brain, brah. Because the big stuff is made out of the little stuff. So how is it that where exactly does the universe change the equation? In between the big stuff and the little small stuff? Where is, that kind of doesn't work. And, usually the response I got after that was like, well, if Einstein didn't figure it out, dude, give it up, brah. Thing is that Einstein didn't have the mathematical tools or, necessarily the data that we have today about what we're finding out in the universe and what we're finding out at the quantum level. So, it would have been harder for him to put it together, a lot harder. And, and as well, Einstein never agreed with some of the fundamental principles of quantum theory, and so he was pushed aside very quickly after writing Relativity. So it was kind of difficult for him to get that. But today is a different it's a different world. And today we've drilled down into, galaxies and stellar objects and atoms. And as we drill down on both sides of these equations, we reach very interesting points. And so when I was doing all this, I was like a heretic, living in a van by myself, isolated. And so I was thinking there must be a connecting point. Can I find a place where Einstein's equation kind of meets quantum theory? Is there something that connects the two? How, if I could find something, just one thing that I can find in both places, then that might be the link that I could, eventually find a unified view from. And I realized when I was studying black holes that Einstein predicts black holes, right? Meaning that Einstein general relativity equation for gravity predicts, a singularity, a point of infinite density in the middle of the black hole. Meaning that space-time is curving to infinity in that place. And I want to mention something really important, is that those equations are used every day by scientists, right, astrophysicists mostly, to describe orbitals or to describe masses of objects in the universe and so on, all the time. And every time they do, they actually describe that mass, they actually describe that object as a black hole. But they don't necessarily pay attention to that. Meaning that if they want to, describe the sun or, the moon or the planet orbiting around the sun, and they want to, calculate the orbits and all this stuff, they start by solving Einstein field equation. They start by solving the Schwarzschild solution, is the solution to Einstein that predicts black holes. They solve that for the sun, and they solve that for the Earth, and then they looked at the orbital relationship between the two. So they've made the sun into a black hole, and they made the Earth into a black hole, but only mathematically, right? And then they describe, they can calculate all the stuff that these objects are doing. But in some ways, not realizing that they've done this. That they've used an equation that says in the center of this gravitational field that you just described, there's a point of singularity, a point of infinite density, right? And because what we do in physics is we only look at the gravity where it's weak, not where it's very, very strong, right? Only where it's strong near black holes, where we say, well, that is a black hole we're observing. So not to confuse you, when I looked at this, I started to realize, well, wait a second. When they do this, they get infinity. And from quantum theory, I knew that when we drilled below the nucleon of an atom, when we went further and further and further, we reached what's called quantum field theory, where not only the particles are quantized, but the electromagnetic field is quantized. And there, the equation as well says there's an infinite amount of energy in every point in space. And I'm like, wait, I got two infinities. I've got two singularities. Maybe this is the connective tissue. Maybe this is where, the two come together. Maybe I can extrapolate the gravitational effect, the singularity of a black hole, out of the vacuum energy infinities at the quantum level, at the very fine level. And in both cases, the equations are renormalized, or there's a cutoff value that's used, so that it's not an infinity in the equation, but it's actually what's called the Planck length. So the two lead directly to the Planck length. And the Planck length is a little electromagnetic fluctuation of 10 to the minus 33 centimeters. So it's teeny, teeny, teeny. That's the wavelength of this oscillator. And it's present everywhere. But basically, this is the cutoff value that was given for the black hole and for quantum field theory. So I know I've lost a whole bunch of you out already. All I'm trying to tell you right now, we're going to drill into this and you'll understand it. It's not that complex. But all I'm trying to tell you is that this little entity, this 10 to the minus 33 thing, this little oscillator, okay, seems to be present in both theories, okay? And it might be the connected dot, literally, of the two. You see, if you were to start, instead of everything is disconnected and everything is independent from each other, to a theory where everything is connected, then you'd have to say, okay, well, what's connecting everything? What is present everywhere that makes it possible for everything to be connected, right? How is it all connected? Because it doesn't appear to be connected in our daily life, other than in a laboratory where we see that particles seems to be entangled. So if you thought of all the things that could connect everything, eventually you would get to this. The only thing you can find everywhere is space, right? Because we have space between galaxies, we have space between planets, stars, all this stuff, there's space everywhere. And if you look at the atomic level, if you take the densest, molecule, like carbon, like diamond, if you grew one of the atoms in that molecule so it's an orange, the other orange would be like 2 football fields away. So there's a lot of space there too. And even the atom has 99.99999% space. I think I got a laser, yeah. And so space is everywhere. And I think this is really significant because you get these spiritual people all the time saying, well, it's so dense down here. And it's like, dude, it's 99.9999999% space. What do you mean? But we pay a lot of attention to the 0.00001%, right? Because we think of that as our reality. Like, in fact, all you have is space that's wiggling a little bit, right? And we call that a reality, and like, you know, we think, all we're touching here is a little solid space. Right? I think, like, actually nothing has ever, I mean, that might be disconcerting for your partner, but nothing has ever touched anything.